Today, we are going to learn about internal structure of root and stem in Cycas. Moving ahead, if we talk about normal root, the internal structure or tissues of normal root can be differentiated into epiplasma, cortex, and central vascular tissue. As we can see here, the transverse section of a normal young root shows an outermost layer of epidermis, also called as epiplasma, which is made up of single layer of thin-walled parenchymatous cell. Below epidermis, there is a multi-layered region called as cortex. It is made up of parenchymatous cells which are filled with starch. Sometimes tannin and mucilate cells are also present in the cortex. The innermost layer of cortex is called as endodermis. Endodermis is characterized by presence of Casparian strips which, which are nothing but waxy suberized coverings present on the radial walls of endodermal cells, an important feature of a root. Just below endodermis, there is present pericycle. Pericycle is again formed of parenchymatous cells, and after pericycle, there are vascular tissues in the central region. Vascular tissues in normal root are central diastele. Diast means presence of two xylem strands. As you can see here in the diagram, there are two xylem strands as well as two phloem strands. Here, exact xylem is present, which means protoxylem is present towards the outer side and metaxylem towards the inner side. Protoxylem and metaxylem also exhibit thickenings, where protoxylem possess spiral thickening and metaxylem have scalariform thickenings. Width in normal root is reduced or completely absent. Talking about secondary growth is also present in normal root. It initiates by formation of cambium strips, which are formed just inner to the primary phloem strands. These cambium strips cut off secondary phloem towards the outer side and secondary xylem towards the inner side, leading to formation of a periderm. Periderm is a collective term for cork, phallogen, and phalloderm. Phallogen is also called as cork cambium, which arises in the cortex region, and it gives rise to cork on its outer side and phalloderm of secondary cortex on its inner side. Here you can see the diagrammatic representation of secondary growth in the normal root. Here in the first diagram, there is appearance of a cambium which give rise to secondary phloem and secondary xylem. Secondary xylem is cut off at the inner side and secondary phloem is cut off at the outer side. Slowly, there is appearance of a cambial ring in the cortex region also, which is also called as cork cambium, which gives rise to cork on the outer side and secondary phloem in the inner side, forming a periderm region, which consists of a phallogen, phalloderm, and cork. Moving on to coralloid root. Coralloid root is similar to that of the normal root, but the unique feature of coralloid root is that here the cortex is differentiated into three distinct regions. First is outer cortex, which consists of compact polygonal cells. You can see here in the diagram that here the cortex is differentiated into outer cortex, middle cortex, and inner cortex. Outer cortex is having polygonal cells. Inner cortex have thin wall parenchymatous cells, and middle cortex forms the algal zone, where endophytic algae such as Anabaena, Nostoc, Oscillatoria are present and live symbiotically for nitrogen fixation. One important point is that the colloid root does not participate in the secondary growth. This is the transverse section of colloid root, where we can see an epiblema, cortex differentiated into outer cortex, algal zone, inner cortex, then followed by epidermis, endodermis, and pericycle and vascular tissues. Internal structure of stem in Cycas. The stem is irregular in outline due to the presence of numerous persistent leaf bases. As we studied previously in that there are woody leaf bases present over the trunk, which are also called as leaf scars. So the stem is irregular in outline, as you can see here in the diagram also, and its internal structure is similar to that of dicot stem. Internal tissues are differentiated into epidermis, cortex, vascular tissues. Epidermis is the outermost layer covered with cuticle, and these scars are also present over the epidermis. Epidermis is followed by cortex, which composed of parenchymatous cells filled with starch grains. It has several mucilaginous canals and leaf traces. The innermost layer of cortex, also called as endodermis, is characterized by presence of Casparian strips, and endodermis and pericycle are indistinct here. Indistinct pericycle means it is not clear. Then comes vascular bundles present in the central region. Here, vascular bundles are arranged in ring, as you can see in the diagram, and has a ectofluic saphenous tail. Vascular bundles are conjoint, collateral, and dark and open. In our upcoming slide, we are going to understand these terms. Ectofluic saphenous tail is the tail where in central region pith is present, surrounded by a xylem, which is further surrounded by a phloem. So this represents a ectofluic saphenous tail in which xylem is surrounded by phloem, where pith is present at the center. Similarly, conjoint, collateral, and dark and open. These are some of the terms you need to understand. Open vascular bundle means that cambium is present. This yellow colored layer is called as cambium, which is present, so vascular bundles are called open. And when this layer is absent, we call them as closed. Conjoint and collateral means here the vascular bundles are that xylem and phloem both are present together, and xylem is present on the inner side of the phloem. You can see here that xylem and phloem are present together, and xylem is present at the inner side of the phloem. Whereas in radial type of vascular bundle, xylem and phloem are not present together and are arranged separately. Whereas in conjoint and collateral, they are arranged on the same radii, xylem placed toward the inner side of the phloem. So, I hope you understand the meaning of conjoint, collateral, open, and endark. Endark vascular bundle means in xylem, protoxylem is present towards the inner side and metaxylem is present towards the outer side. If this is a xylem, you can see here that smaller young vascular bundle which are protoxylem are present towards the inner side and mature or metaxylem are present towards the outer side, which are the bigger vascular bundles. So this arrangement is called as endark arrangement, which is opposite to that of the root, which is called as exarch, where protoxylem is present towards the outer side. Pith is composed of parenchymatous cells. You can see the transverse section of the stem where there's armor of leaf bases or leaf scars present over the stem. Over the epidermis, it is followed by a multi-layered cortex region, and the cortex is followed by endodermis. Pericycle is not very clear, vascular bundles, and pith. Cortex is transverse by mucilaginous canals. Yes, you can see here mucilaginous duct. And this is the transverse section or internal structure of the stem in Cycas. In stem, numerous leaf traces can be seen in the cortical region. What are the leaf traces? These are the vascular strands which supply the leaves, and each leaf receives 4 leaf traces. 2 traces arises same side as the leaf and directly enter to the leaf. These are called as direct leaf traces. You can see in the diagram that this is the pith. Within pith there are vascular tissues or vascular cylinder. They are directly supplying. They are directly supplying the leaf trace. Okay, so there's a direct leaf trace towards the leaf, whereas other 2 traces arises the leaf and enter the leaf after turning around the vascular cylinder. You can see here that they are turning around the vascular cylinder and then entering the leaf. So there are two direct leaf traces and 2 indirect leaf traces, which are also called as girder traces. Secondary growth in stem. Here, stem shows secondary growth by the formation of interfascicular cambium. Parenchymatous cells which are present between the vascular bundles become undifferentiated and they form interfascicular cambium cells which combine with the cambium cells present between the xylem and phloem in the vascular bundle and form a complete cambium ring. This cambium ring started activity and it cut off secondary xylem towards the inner side and secondary phloem towards the outer side. Secondary growth in stem is now it becomes a regular process where activity of the first cambium ring ceases shortly and a second cambium ring shortly differentiates in the inner cortical region, which starts its activity and form a second cambium ring again, alternating secondary xylem and secondary phloem again. So, such cambium rings are formed, and after this cambium becomes inactive and another cambium ring is again formed, which lead to the generation of many rings. In Cycas pactinata, there are 20 rings of cambium formed. Extrastellar secondary growth take place with the formation of cork cambium, which is also called as phallogen, which is formed in the outer cortex. This cork cambium cut off cork on the outer side and secondary cortex in the inner side, which is also called as phalloderm. So, a collective term called periderm is used for cork, phallogen or cork cambium, and phalloderm or secondary cortex. These are followed by rings of xylem which are made by the activity of cambial rings. So this is all about the secondary growth in stem. Thank you.